Assalamualaikum and hello. In this video, I'm going to teach you how to calculate the relative atomic mass AR from the mass spectrum. From the previous video, I've taught you how to calculate the relative atomic mass based on the ratio. But right now, we are going to go a bit more up level, how to calculate based on the mass spectrum. So we got two steps here. The first one is determine the average atomic mass. So average atomic mass is the summation of Qi times with Mi over summation of Qi. So what are those Qi and Mi? Qi stands for the relative abundance or percentage abundance of an isotope of the element. So this one is referring to the y-axis in your mass spectrum graph. Next one, we have Mi. So Mi is the relative isotopic mass of the element. Relative isotopic mass of element is depending on the questions given. Sometimes it will give you in 4 decimal places, or sometimes it just give you in 2 significant figures. So depends on the questions given, you are going to use that value for relative isotopic mass. Next part, you have to remember the unit for average atomic mass is still atomic mass unit, AMU. Once we go to step number 2, you have to compare the mass of 1/12 of carbon-12. This is where you are going to put the term relative atomic mass. This term relative, by using this formula that you've learned so far, you can put the value that you got from step 1 on the top and over 1/12 times 12.0 for the mass of one atom of carbon-12, AMU. So this is where you will get your final answer with a specific value without units. So please remember, once you see the term relative, it must has no units. So let's go to example 1. I have here a spectrum and I want you to determine the relative atomic mass of magnesium. So how to do this one? Use the step that I've taught you in the previous slide. Step 1, find the average atomic mass first. So you will use Kimi-Ki. That's the short form for me so that I can understand what I'm trying to find out. So I have average atomic mass, Kimi-Ki, equals to, we got 63 here for isotope 24. So times plus, we got 8.1 times 25 plus, we got the third line 9.1 times 26. So all of this summation over with 63 plus 8.1 plus 9.1, which is the relative abundance, Qi. And you put all this value into your calculator, you will get the final value 24.3279 AMU. Please remember, you still have to put the units for this one because you are calculating the average atomic mass. Now we go to the second step, step 2, by using the relative formula to get the relative mass without units. So I'm going to put AR for magnesium. AR is the short form for relative atomic mass, equals to 24.3279 AMU that you got from step 1 over 1/12 of carbon-12 atom. So you will get the final value same but without units. So this is the final answer for solution of example 1. Let's try one more example where I ask you to calculate the relative atomic mass of naturally occurring sulfur from this data. So right now they give you the data instead of mass spectrum. But don't worry, just calculate by using Kimi-Ki. So I'm going to calculate the average atomic mass, Kimi-Ki. All of this value, 32 times 95 plus 33 times 0.76 plus 34 times 4.24 over 100, because we have 95 plus 0.76 plus 4.24. So you will get the value 32.1 AMU. And in order for you to calculate the second step, relative atomic mass, equals to 32.1 AMU over 1/12 of carbon-12 AMU. So final value is 32.1. So this is how you want to use your Kimiki in answering the mass spectrometry question. Now let's try example 3. So for example 3, I got my mass spectrum here on the left, and it shows the mass spectrum of the element rubidium, Rb. So what isotopes are present in Rb? This is where you are going to put your answer in isotope notation. So you will have two of isotopes. The first one is rubidium 85 and the second one is rubidium 87. So this is referring to the nucleon number. So I'm going to put my mass number like this one, 85 Rb and 87 Rb. So that's how you write down what isotopes are present in Rb. Settle for question A. Now we go to question B. What is the percentage abundance of each isotope? If you take a look here, you need to calculate the percentage abundance of each isotope. So we are going to use the value for each of them one by one. So let's try for rubidium 85 first. So I got 18 from the relative abundance over 18 plus 7 times 100. It's just a mathematical to get the percentage. So you got 72% abundance for rubidium 85. Now let's try for rubidium 87. It's just the same thing but different value because you got 7 for the value of relative abundance of rubidium 87. So I will have this one as my final percentage abundance, 28% of rubidium 87. Now we got question C, which is you have to calculate the relative atomic mass of rubidium. So how you want to do this one? Use the two steps that I've taught before. You got your own value, so put in the formula Kimiki. You will have 85.56 AMU. And next, you are going to calculate the relative atomic mass of rubidium, AR. So by comparing to 1/12 of carbon-12, you will have 85.56 without units. So this solution is for 3 questions of example 3. Now let's go to example 4. I have a bit different right now, which is in ratio. So we got the ratio of relative abundance of naturally occurring of chlorine isotopes. So we have chlorine 35 and chlorine 37, 2 isotopes of chlorine. And the ratio between these two equals to 3.127. So based on carbon-12 scale, the relative atomic mass of chlorine 35 and chlorine 37 as stated in this part. So you need to calculate the AR relative atomic mass for chlorine. I got the final answer here, so I'm going to give the working calculation. First thing first, you got the ratio. So this is the ratio for 2 isotopes for chlorine. As I mentioned before, if you realize this is a fraction, so 3.127 actually over 1. So you can understand the ratio for chlorine 37 is 1.0. So applying by using the formula Kimiki, you are going to put the value by times with the relative atomic mass given in the question before. So I'm going to choose 3.127 for Qi times with 34.9689 based on the questions given for Mi plus 1.000 from here for chlorine 37 times with 36.9659. This is also given from the question. So in this part, it wants to test you whether you follow the instruction or not, because sometimes we just calculate by using 35 and 37. But in this question, no, you have to use the value given based on relative atomic mass in the question. So I hope you can realize a bit different about this question. And continue with Kimiki. Over the total of Qi, we have 3.127 plus 1.00. So I will have 35.45 AMU. So a bit different here. Typo for my part. So now you got average atomic mass for chlorine. And I'm going to calculate the relative atomic mass, AR for chlorine, equals to, put in the formula, and you will have 35.45 without units. So I hope from these 4 examples, you can understand how to use Kimiki and how to answer and describe the question about mass spectrometry. So I leave try this 1 until try this 4 for you to test your understanding. And now we settle for subtopic 1.1, atoms and molecules. So we are going to continue for the next subtopic in the next video. Thank you.